My looks would change feathers. A dwarf. I will kill you. Is that the best? Is that the
Nightly Knockout is a first-person, networked multiplayer 1v1 sword dueling game. Here are the controls for the game. Here is the 404 page for the game. Diagram of the game you buy. Here's the game working on mobile phone. Here's a description of how the game progressively gets more difficult. When signing up, user data is sent to the server and stored on a SQL database. The profile picture is uploaded using Malta and saved on the server's local storage. When a player logs in, the client sends a GET request to the server with the username and password. The server will return the information about the user or an error. Player data is then saved to session storage so they can play without having to re-log in. After the game, the player stats will be updated and saved to the server. The database requires a password to access, which is securely stored on the server, not the client. Replit projects are served using HTTPS, meaning communications including passwords are encrypted. Also, the server hashes the password before storing it on the database. Meshes are low poly and have low res textures to keep the game loading relatively fast. Instancing is used to create complex geometry clouds in the sky. The project has a README which is attached to the GitHub. As mentioned previously, the game is network multiplayer. The networking code is handled using Socket.io. The game follows a client-server communication model. A client sends a message to the server which is relayed to other clients. In the main menu there is a game or server browser. A player can create a new game and all players should be able to see and try join that game. When a client opens the main menu, a new socket instance is created. The server then sends a message to the client with all the games currently created or being played. The client can then update their front end accordingly. A few more clients can now join and will be updated. Then a client can create a new game. A message is sent to the server to notify them that a new game is to be created. The server will create the game and send a message back to update all of the client's front ends. The name of each game is used as a socket room on the server side, so that only clients in the same game will receive messages. This allows for multiple games to be played simultaneously. The game uses physics for collision detection to keep the player within the map, to detect collisions between the player sword and enemy, and to move the player. To implement this, I used a library called Ammo.js. I used the following articles as guidance of how to implement the physics into the game. When using a physics engine, you have to think of the game world as two separate worlds, a rendering world and a physics world. There are three types of rigid bodies in ammo. Player inputs set the velocity of the capsule rigid body, and the player model's position is updated to match said rigid body. The final setup for the world that I decided on was to have a dynamic capsule as the player, static walls and floor to constrain the player in the map, and a kinematic enemy capsule and a kinematic player sword. The player can move their own dynamic capsule and its position will be networked to the enemy, who will update the transform of the enemy kinematic capsule. This way movements can be synced and both players behave in a physically simulated way. The client will have a kinematic cylinder which will match the positions of the player's sword. To stop the kinematic sword from moving the player's rigid body, I have set up collision groups and masks so that the collisions between the sword and player will be ignored, but not between the player and the environment, or the player and the enemy, or the player sword and the enemy. When a collision is detected, the program checks if it's the enemy and the sword that are colliding. If it is, an attack landed or attack blocked message is sent to the server.